Bismillahirrahmanirrahim. I'm Marwah Alian. I'm going to present my paper evaluating factors affecting sentences similarity and paraphrasing identification using k-means clustering. Now, the agenda of this presentation will be research objectives, paraphrasing identification, Arabic paraphrasing benchmark, factors affecting sentence similarity, experiments and the results, and finally conclusion. The research objectives. The aim of this research is to analyze the constructed paraphrasing benchmark using the k-means clustering by analyzing and studying the factors that affect the results of similarity and the distribution of sentences. The k-means is considered as the simplest method used for partitioning dataset into clusters of similar objects. Therefore, it is applied to the dataset after representing the sentences as vectors in the continuous vector space using word-to-vec model. Paraphrasing identification. Paraphrasing is the restatement of a text to produce the same meaning using another form, while paraphrasing identification task is the task of detecting if two texts are a paraphrase of each other or not. This task, together with semantic similarity, has shown to be useful features for improving many NLP applications, such as question answering, information retrieval, text entailment, and many others. Arabic paraphrasing benchmark. This benchmark is constructed from Arabic sentences that are collected from several books used for teaching Arabic language, such as Jordanian curriculums for Arabic language and other books. Experts in Arabic language create a number of sentences based on words from some Arabic lexicons and the words from Arabic word semantic similarity dataset. The transformation rules were applied on the collected sentences by two experts in Arabic language to produce the transformed sentences. Now, transformation rules, we have permutation, which means changing the order of the words in the sentence. Deletion, to delete one word. Addition is to add one word to the structure of the sentence. Expansion is to add two phrases instead of one. Reduction is to replace two words by one word. Replacement is to replace one word by another word. Maybe it's the same meaning or not. Factors affecting sentence similarity. Three factors that affect sentences similarity and paraphrasing identification are evaluated using k-means clustering in this research. The first factor is the approach used for providing sentences embeddings, trained and pre-trained embeddings. The second factor is introducing the weight of words. The third factor is the way of labeling the dataset by majority or by similarity score threshold. The resulted clusters that contain similar sentences are compared with the labeled dataset using recall and precision measures. Now, the first factor, self-trained word-to-vec word embeddings versus pre-trained word-to-vec. Two experiments are conducted for this factor. The first experiment is based on self-trained of word-to-vec on the dataset that consists of 2020 sentences with 3,145 vocabulary. The second experiment is constructed on pre-trained embeddings using Arabic that utilizes this huge number of Arabic tweets gathered from different locations in the training of word-to-vec. The vector that represents a sentence in both experiments has constructed as the mean of its content words vectors. As we can see, the results of these experiments, the self-trained embeddings provide better recall in the similarity and provides better recall in paraphrasing identification, while the self-trained, while the self-trained is provided more precision than the pre-trained, while pre-trained provides more recall in both similarity and paraphrasing identification. This is for pre-trained and this is for self-trained. Now the TF-IDF weight, we have two experiments, one with the TF-IDF and the other without including the weight. We have here better recall, little bit better than the k-means without TF-IDF. Now labeling dataset, we use two methods to provide the final label to the dataset. In the first method, we use the label of each sentence pair for similarity by majority of experts' decision about similarity. If more than 3 experts give a decision of similarity for a sentence pair, then this pair is labeled as similar, otherwise it's labeled as non-similar. In the second method, we compute the average of the score of similarity provided by the experts. A sentence pair is labeled as similar if the score average is greater than or equal 50%. Otherwise, the sentence pair is labeled as non-similar. You can see here the labeling by majority and the results of score labeling. We have here a better recall and better recall for k-means with TF-IDF than this one. And we have here by labeling with average score better precision. Okay, while F score is better with the labeling by majority. Finally, we conclude in this research, k-means clustering is applied to Arabic paraphrasing benchmark to explore the dataset as clusters of similar sentences and experiment which pairs are paraphrased and allocated in the same cluster. The recall achieves better values with the pre-trained Arabic embeddings in similarity detection and paraphrasing identification, while the precision with the dataset training embeddings provide better value for paraphrasing identification. When we include the weight for each word to produce the embedding of a sentence, the results for paraphrasing identification is little better than the results without taking the weight into consideration. It is also shown that labeling by majority provides better recall for k-means with TF-IDF weighted embeddings. And thank you.